Welcome back to Way of the Wrench, and on today's very special episode of How to Become a Welder, I'm going to show you everything you need to know to get yourself up and running using a TIG welder. Now, there's a lot of videos already out there, so my challenge today is to make sure that this video is very easy to learn and very memorable so that you guys know what you're doing. So, challenge accepted. Let's go learn some TIG. First logical question is, what is TIG welding? Well, TIG stands for tungsten inert gas, and otherwise in industry known as GTAW, which is gas tungsten arc welding. So it is definitely within the family of electric welders. Now, the tungsten refers to the type of material that this electrode is made of that sits in your torch. And then the inert gas is what is in this bottle back here. And that gas acts as a shielding agent to prevent the atmosphere, so oxygen, carbon dioxide, nitrogen, from getting into our liquid metal, making porosity. And it also helps to protect corrosion on our electrode when it is crazy hot. So the next question is, why would we be using TIG welding as opposed to gas, MIG, or stick welding? Well, they all have their pros and cons. So TIG welding, I would say a con for TIG welding is that it is a bit of a slower process. However, I also think of that as a pro. Because it's a bit slower, you can focus on making sure that those welds turn out absolutely beautiful. Now, a big plus for TIG is that you have ultimate control over the amount of heat input. So less distortion, less warping on parts, and not only can you control that, you can control it on the fly because you have a foot pedal that basically can make it so that you have zero heat getting inputted to all the way to maximum what you've set on the machine. So really cool control that you can adjust on the fly. So thick parts that go thinner and you're welding them on, or a part where you're welding and you got even heat, but when you get to the end, the heat's not dissipating, you can back off on the heat to make that weld absolutely perfect. And speaking of gas welding, I find that any skills you have in gas welding, those completely transfer over to being a good TIG welder. You've got your heat source, which instead of it being an open flame, we're using electricity, and you can weld without filler rods, or you can add filler rods to the mix, or brazing, and all of the skills are going to be the same. Now, the only thing we're adding to the mix is that foot pedal we just mentioned, so that gives us even more control over the heat coming off. All right, now let's take a look at the actual TIG torch parts themselves. Now, this is the torch body, which also includes the power cable and the hose for the electricity and the shielding gas to come out to the end. Now the next part is the gas nozzle. Now this thing here, it basically has a hole in the middle and 4 holes on the side here to allow the gas to come out around the electrode and shield where you're welding. You can actually get upgrades of these, which are gas lenses. Essentially there is a screen mesh here that prevents the gases from coming out in kind of a turbulent flow. Kind of helps make the gas just go out straighter and a little bit less turbulent. Now this gets spun into the front, and make sure you're not cross-threading it. It should go in very easy, and do not use tools. Everything here is going to be by hand. Make sure this is snug, otherwise you're going to have problems with your electrode being loose. Now, the next thing is the actual electrode themselves. So, the most common electrode that you're going to use is going to have a red band on it, and it's the 2% thoriated tungsten electrode. This is going to be used pretty much all the time. The only other common one is going to have a green band on it, and that's going to be 100% tungsten, which is usually used for AC and aluminum welding. Now, we're going to sharpen this later, and I'll show you that in a sec, but the pointy side goes in like that. This part is the collet. Now, this goes in and is what is going to hold this once it's all tightened up. Now, for right now, this thing is loose. And even when you put it in here, it's loose. So the next part is what tightens it up. Now this is the back cap, and they can come in different lengths. It really doesn't matter. The longer lengths allow you to have a longer electrode in here, so you don't have to cut them down as much. But sometimes these get really long and in the way, so you can get medium size and even short little stubby caps. Now there is a little O-ring here, so that as you tighten it up, that prevents the shielding gases from escaping out the back. So maybe just take a look at the condition of that. And then this surface here, when you go to tighten it up, it's going to push on the end of the collet, which pushes it against the gas nozzle and then clamps down on the electrode. So that prevents the electrode from moving once you have set it. So I'll spin this in. Once again, make sure it's not cross-threaded by hand. And we're going to tighten it up. And you can see that this is now tight. And if I loosen it, I can adjust this. Now, the last piece is our gas cup. Now, these can come in different sizes, little stubby guys, kind of bigger, wider ones that taper down. It's all kind of personal preference and getting access to get into where you need to weld. They also sell kind of very cool aftermarket ones that work well with gas lenses that are a little clear and a little bigger so that you can see better. But this one here is just one of the normal kind of ceramic ones. Now, these is almost the most consumable thing that you use when you're TIG welding. They hold up to heat really great, but when you put the torch down aggressively or drop this, these tend to break and shatter, and then you have to replace them. So make sure you got lots of these on hand. Okay, this spins on to the gas nozzle. Once again, make sure it's nice and snug by hand. And then the only other thing left is how far should this stick out? Now, if you have it too far in there, this will be so close to your material you won't be able to see what you're doing. If you have this sticking out way too far, then there's a big danger of not having enough shielding gas to protect the electrode and the weld that you're doing. So there is a set dimension, and what it is roughly the size of the hole in the gas cup here is how far that should be sticking out. So just by eye, that's close enough. Something no more than that. And you can creep in a little bit more if you want. Okay, then give it a snug. And then you're ready to TIG weld. Now, let's take a look at how to sharpen these tungstens when they get bad. When you go to grind your electrodes, if you're using brand new ones, make sure you get the right size diameter that works with the collet you have in your TIG torch. If it's not the right size, this won't go into the collet, or it will go in, but you won't be able to tighten it up and the electrode will be loose. Now, the other thing is these electrodes come really quite long, often too long to fit inside the back cap. So if that's the case, take a corner of the wheel of the bench grinder or a zip disc and cut this right in half, and that gives you 2 brand new electrodes. Now, the other thing is this is a used electrode. The chances of the end being contaminated by accidentally dipping it into the puddle with whatever material you were welding is very highly likely. So what you're going to do is you're going to grind all that off, and it can be a little tricky to see. So if it's a big blob of it, you might even want to just cut off about 2-3 millimeters and then restart the grind. Let me show you what I'm using. Now, when I grind my electrodes, I use a bench grinder like this with the techniques I'm going to show you in a second. However, you can buy specific tungsten electrode grinding machines out there, and I'm sure they work well. I just have never ever tried or purchased one because I've always had one of these. So let me show you the technique. So the first step is we have to grind roughly a 30-degree angle on the end of the electrode to a point. Now the trick is trying to make it even as you spin it around. So use these 2 fingers to support it, and your thumb and finger over here is going to rotate the electrode while you hold the angle, and then just keep going until it's nice and even around. If it gets too hot, don't forget you got a quench tank there. Now that we have that 30-degree angle on there, but because we did it like this, the grinding marks kind of make the electricity or the arc kind of jump off a little funky and hard to control. So now what we want to do is make the sparks go with or parallel with the electrode. And the way you do that is now we go like this on the grinding wheel and go up high. And we're going to do the same kind of technique, except we are just going until the lines are going straight with this. So it's not as heavy as a grind. So the very last thing we have to do to this electrode is put a little flat spot on the end. And the reason why is even though tungsten is really good at holding up to high heat, even tungsten, when it gets to a very sharp, thin, tiny point, it will have some erosion happen there, and then that will direct the arc kind of funky and not where we want it to go. So by grinding a little flat, and I kind of recommend about a 1 millimeter flat, but it does depend on what you're welding and what your amperage is. But I usually just grind a 1 mil flat on the end, and that will help prevent that from happening. So just kind of blunt it like this and take a look at it. And if it's 1 mil, you're good. If not, do a little more. And if you go too far, you're just going to go back and grind the angle a bit more. And when you're learning how to TIG weld, the chances of dipping is really quite often. So instead of just doing this and hopping back and forth between the TIG welder and the bench grinder, why don't you grind a couple of these? That way you can just quickly transfer them out. And then once you got 4 or 5 of these that are all contaminated, you go grind them all at once. Now, as for your shielding gases, most of the time you're going to be using 100% argon with TIG welding. However, different materials, and if you require better penetration, you may start switching up to something like 100% helium or a helium-argon mix. But in most cases, and what I'm using today is 100% argon. Now, the setup for these bottles is exactly the same as the gas welding, so if you watch that video, you'll know what's up. You have a main cylinder valve up here, lefty-loosey all the way open when you use it. Because of the high pressure, there's a double sealing valve, so it has to open all the way. Now, there's a couple different types of regulators. So there's this type, and there's the flow meter with the little floating ball. They both do the same thing. But in this one, the gauge that has the bigger numbers, that's telling you what the pressure is inside of the cylinder. And then the one over here that says cubic feet per hour, that is what you are regulating that flow out to your electrode. Now, in most cases, you're going to be setting that flow to about 15 to 20 cubic feet per hour. That'll get you what you need. However, it can change depending on what you're doing and the conditions of your welding. Now, some general guidelines: if you have not enough flow, then you just don't have enough big enough shield gas around your weld puddle, and you'll start to introduce some porosity from outside atmosphere. And when you crank it up, 30, 40, 50 cubic feet per hour, that doesn't necessarily make it better. What happens is you have such fast flowing gas out the end of your electrode and out of your gas cup that it starts to cause turbulence, kind of like this, where it brings in oxygen and actually causes porosity. So you do want to get it around 15 to 20 cubic feet per hour. Now, when you go to set your flow rate, it's important that you turn on the machine and you will hear and see the flow coming out from your gas cup. That's when you need to adjust the regulator to get to that 15 to 20 cubic feet per hour. Now, why I'm saying this is, if you look at this gauge, that looks great. But if I shut this off, and if somebody backs this regulator off to closed, the next person that comes on, they think they just have to turn this on, and they look at the gauges and it says we're all good. However, as soon as you turn on the machine, you're going to see this needle drop down to 0, and that's because this regulator has been backed off. Now, for setting up this machine, every machine is going to be slightly different, but there are a lot of basics that are all very common. Now, I'm using a Lincoln 225 Precision TIG. It's a TIG/stick, which is very convenient, so you can do stick welding with it as well. So let's show you how to set this up. The first thing we're going to do is hook up our ground clamp. Now, this should go right onto the workpiece itself, or if you're welding on a nice clean metal table, you can clamp it to that, but just make sure that you're clamping it to metal, not paint. Now, for the main cables coming out of the machine, this was the ground clamp right here, so it says putting it to the work. This is the remote or the pedal, so this one goes to that pedal over there. And then this one here can change whether you're doing the actual TIG or stick, and this one you just let it turn counterclockwise, and it pops out, and it's got this kind of unique end that only goes in one way. So if you're doing stick, then grab the end that looks like that goes to the stick electrode holder, or since we're doing TIG, we're going to put this one in. The next setting is whether we put it on DC negative, AC, or DC positive, and it looks very confusing, especially when you're first starting out. However, it's not that bad. 9 times out of 10, you're going to be leaving it on DC negative. This is going to allow you to weld steel, stainless, cast iron, just about everything you're doing is DC negative. Now, about the only time that you put it to AC is when you are welding aluminum, and we'll get into that in a bit. The DC positive is only on this machine because it actually has stick welding capabilities, and there are some flux coatings on the electrodes for stick welding that require or do better on DC positive. So most of the time, you're going to be on DC negative. All right, for the next panel, we need to turn this on. So this is your on-off switch. And if I have to explain that this is an on-off power switch, maybe you should not be touching a TIG welder. Once you turn your machine on, we have a mode selector switch. So that just switches from stick to TIG. So obviously we want it on TIG. This LED display is in amperage, and this is what the maximum amperage that you can get when you have the pedal all the way down to the ground. So in this case, 46 amps. Now, to adjust that, you've got an output dial here, so you can go up or down with it. Now, to be able to figure out what you should be setting this for to start with, it has a lot of variables. It depends on the type of material, how thick the material is, whether you're using a filler rod or not, and the diameter of the filler rod, and then how fast you actually want to be welding or slow. So there's a lot of factors. So rather than kind of run through a whole bunch of stuff here, I would say that a good starting point is 16 gauge sheet metal. Carbon steel should be around 60 amps. If you got something a little bit different, thicker, you got to go higher amperage. Thinner, you got to go less. What I'll do is I'll put a link down in the video description so that you can have a good reference chart for you so that you can quickly get to a good starting point, and then you adjust on after that. Now, post-flow, this one's really easy. This is the length of time in seconds that the gas, the shielding gas, will continue to come out after you are done welding to protect the weld and protect the electrode. So you should always have this on. I would say probably about 5 to 10 seconds is about good enough. Anything more than that, I think that's a bit wasteful. Now, this pulse frequency, this is really good for welding thin materials where you do not want to put a lot of heat in. Now, with it off, it does absolutely nothing. It gives you the full amperage that you want all the time. However, when you start coming off the off here, you can have basically 1 hertz all the way to about 20 hertz. And what this is if you look, this light's flashing. And when the light is flashing, that is giving 100% of what you've asked for, depending on where your pedal is. Now, when the light is flashing off, it is giving you a reduced amount of this. It could be capped at something like 30%, or it could be 50% of this. It just depends on the machine. Now, you can see as I increase this that flashing speeds up. So the longer the pulses, the less heat. The faster the pulses, you're still getting quite close to what it would be at full bore there. Now, besides putting in less heat, because it basically puts in heat and then backs off the heat, the other thing is you can use this to help you when you're beginning trying to figure out your timing for adding your filler rods. If you stick closer to like 1 to 3 hertz, every time that flashes, it'll make a puddle. You could be adding your filler rod there and then backing off, adding, backing off, adding. So it kind of helps you in the beginning with having a really good regular bead. Now the last one here is AC balance. So this is when you're using AC and pretty much welding aluminum. 3 settings on this one. You've got automatic, where it's going to adjust the balance of cleaning to penetration, or you can have more cleaning, or you can adjust all the way to have it more penetration. Now what this is actually doing is it is adjusting the AC sine wave. So you have a positive curve and then you have a negative curve. And think of the 0 point as kind of not positive or negative, but neutral. Now when you are adjusting it to penetration, you are having that line where the positive and the negative, you are adjusting where that line is. So if you have it on penetration, there's going to be more of the time in the negative curve, which helps with more heat and more penetration. Or if you go to a cleaning cycle, what happens is it adjusts the bar so that there is more of the positive side of the voltage. And this really helps clean up the oxides when you're doing welding aluminum. Now, an auto for this machine basically just finely balances what you need on the fly so that you don't have to mess with it too much. Now, before we do some TIG welding, we do need to talk about safety. However, in the interest of keeping these videos a little shorter and sweeter for you guys, I have gone ahead and already made an excellent video on how to keep yourself safe with any kind of electric welding. So whether you are welding MIG, stick, or TIG, the safety is much the same. So I will post a link to the video above so you can watch that. Please watch that before you do any kind of TIG welding. And your machine has an owner's manual, a whole section on safety, and on the outside there's a whole bunch of warnings and safety labels. So don't be a dummy, make sure you read that stuff and keep yourself safe. Now my video will cover everything you need to, right down to your personal protection equipment, what you should be wearing to keep yourself healthy and safe, your work area, making sure that you're not going to cause fires, explosions, welding with wet conditions, and keeping people safe around you. And then anything specific with electricity, such as you physically not becoming part of the electric circuit and getting electrocuted. So please watch that video before you go and start this on your own. Before we do a TIG weld here, I thought I'd give you some more basics to get you started off on the right foot. So the very first thing is you hold the TIG torch in whatever hand that you normally write or draw with. That way you have greater precision control over the actual puddle itself. Now you are also going to hold it like a pencil. So you are not holding it like a hammer or a caveman chucking spears. You want to hold it like a pencil. Now the next thing is the distance between the tip of the electrode and the workpiece should be about 1/8 of an inch. If you're too close, then you're going to have problems with the electrode dipping into the puddle and having to stop and regrind. And the further away than 1/8 inch you get, you're going to have issues where you're going to get more porosity because the gas shield can't cover that much. Now, as for where you point this, I would start at straight up and down and go roughly 20 degrees in the direction that you are moving. So this is a push process. And the reason why is if it was straight up and down, you'd get really good gas coverage, but you cannot physically see the distance now between, and you're going to end up dipping. And if you have an excessive forward angle on it, you're actually got two problems. First one is the gas coming out this way is actually going to cause some turbulence and start sucking in some atmosphere. So we don't want that. And then the other thing is you tend to think the electricity would just jump straight off the tip at whatever angle this is. However, electricity always takes the path of least resistance. So if it's a shorter distance to jump straight down, you're going to have the arc going weird and going down. So about 20 degrees in the direction that you're going. Now, if you're not using filler rod, then your other hand's free. However, if you're using filler rod, the angle that you're going to be using this is much the same except from the workpiece up about 20 degrees. That way that gives you enough room to get in, dip it into the puddle and get it out without touching the electrode and contaminating that, and still being able to see what you're doing. Now, as for the foot puddle itself, you're going to use whatever foot that you feel you have more control with. For me, being a car guy and driving lots of manuals, I feel that my left foot, because it's my clutch foot, is way better at controlling that. So I use the left foot. However, it doesn't really matter. And in some weird situations, you may have to actually switch up to your right foot. Now, rather than me going on and on for the next 10 minutes about all of the different beautiful tips and tricks I could give you from my own experience, I have a great video. I will put a link up of that for you. It's 20 minutes long and it gives you my top 10 tricks on how to become a better welder. Watch that. I think it's well worth your time. A couple other important things about TIG welding. When you go to grab some gloves, don't reach for these big, thick, heavy, durable stick welding gloves. Go and get yourself a thin pair of deerskin gloves that are meant for TIG welding. It will make the experience much more enjoyable and you'll have a lot more precision control over the torch. Now, the other thing about TIG welding is it requires the material to be very, very clean. So before you do any welding, get a grinder or a roll-lock disc on an air grinder and clean your material really well. That way there is no rust, mill scale, paint, or if you're working with aluminum, you got to get that aluminum oxides off the surface. Now, I'm going to be doing a bead for you guys with filler rod. So the other important thing is make sure that your filler rod is the same material as the base metal or at least compatible with it. So I've just got some low carbon steel here, some flat bar, and a mild steel welding rod. So let's run a bead. To initiate the arc, you just start pushing down on the pedal and eventually you'll start to see some arcing happen. And when you push a little bit further, you'll see it kind of stabilize and then heat will start to go and a little bit of puddle will form underneath like this. Okay, once you get a puddle started, put a little material, get some heat in there first, and then start moving. And you're watching a bunch of stuff, where you're going, the distance, that 1/8 of an inch from the electrode tip to the material, and you start to get into a rhythm of how often you're adding the filler rod, so kind of like the intervals, and how much or how long are you leaving that filler rod in the puddle. You want to kind of aim that filler rod for the center of the puddle, not the edge. Otherwise what tends to happen is it sticks and the only way you're going to get it off is getting that heat from the torch to melt it off again. Okay, and you're watching the edge of the puddle, trying to keep that puddle the same size as you're moving along, trying to keep it straight and on track with your mark. Trying to be as smooth and as steady with the torch as possible. Any little shaking is going to get put right into your weld bead. Now this is running 75 amps. This is kind of slow. It probably could be turned up a bit. And I do have the pedal to the max. So one benefit of setting this to a little slightly hotter on the machine, maybe if I had 100 amps or something like that, I could back off on the pedal to control that heat. Yet if I needed the heat, I could put it in. Now when I get near the end, I'll have to taper off here so that the heat can dissipate. And you don't just shut off the pedal, you can kind of go slow with it. That way you don't end up with a little pinhole in your weld bead. Like this. And then until that red glow is gone out of the steel, or at least until the post flow of 4 or 5 seconds is done, keep the torch there to protect your weld bead and your electrode. All right, let's take a look at this weld. So I started here and went in this direction, and the first thing I look for is it too hot or too cold? Well, there's a decent kind of lump to this weld bead, so that's good. It's not concave or flush with the surface, meaning it's too hot, and it's not sitting up like a bird poop or a worm on top, meaning it's too cold. Now, the width of this weld bead is a decent size, and it stays consistent throughout, so that means the heat didn't change and the amount of filler rod was pretty consistent. The other thing is there is a C pattern here that we can see. That's your individual puddle that is solidifying as you move away. And the distance between those C's is fairly regular. So that means the movement of the torch was steady and the intervals for dipping the filler rod in the puddle were fairly consistent as well. There is not a single pinhole in this whole thing. There is no crater at the beginning of this weld, so I paused long enough to get some material in there and get a bead started before I started moving away. At the end, hard to see. You probably could put a little bit more filler rod in here to cap it a bit better, but definitely not a crater. No pinholes. And let's see for strength. You can see there's a little bit of melting through in the backside, so definitely a strong weld as well. So, not too shabby. Not my best work. Definitely I can see that I tried to stay as straight as I could, but there's a little bit of an arc in here. It's a little harder when you're just doing a weld bead on a top of a piece of metal. If you're doing a corner joint or a lap joint or a T-joint, then you got something kind of definite to keep you on track that way. But overall, pretty good. All right, that's a wrap on another video from Way of the Wrench and on how to become a welder. This time on all the basic stuff to get you going with TIG welding. So at this point, I highly recommend you go clean up some material, get some filler rods, and get some time doing some TIG welding and learn how to diagnose those weld beads so that you can improve with every one you do. Look forward to lots of future TIG content, including how to TIG weld stainless, TIG weld aluminum casting repair, and all different kind of projects, including some TIG art, which would be really quite cool. So if you haven't already, why don't you subscribe, and while you're at it, hit the post bell notification. That way when a new video drops, you will know about it right away. And if you haven't already, why don't you join us on Instagram? That way you can see all the behind the scenes stuff between videos that's going on in the shop. Until next time, take it easy.